The purpose of this lab is to design an experiment to measure and calculate the coefficient of friction between two surfaces. The materials we used for this lab were a wood plank, 3 metal poles, 3 clamps, a protractor with a string contraption, a cart with a plastic bottom, 2 photo gates and appropriate software, a meter stick, and a camera. Step 1. First gather materials. For Step 2, secure the wooden board at an angle onto the pipes with clamps. Step 3. Measure the angle using a protractor. For Step 4, set up the photo gate so that the first one is a meter's length apart on the wooden board from the last one. For Step 5, put the cart in the start position and release from rest. Step 6. Measure the time it takes for the cart to slide on the board. Step 7. Repeat Step 6 3 times for different trials and find the average. Step 8. Repeat Steps 2 through 7 for 2 different angles. Step 9. Record all findings in a data table. For Step 10, use the time and ending velocity found from the photo gates and a Vividet equation to find the acceleration. Step 11. Using the acceleration, you can now solve for the forces to find the force of friction. Step 12. Once you have found the force of friction, you can now solve for the correlational coefficient, or mu, of the plastic cart on the wooden board. To find acceleration, we use the constant acceleration Vividet equation. This is displacement equals v initial times time plus 1/2 acceleration time squared. Then we plug that into the acceleration equals sum of the forces over m in the x direction, which is mgx minus force friction all over m. Then this becomes acceleration equals mass times gravity times sine theta minus mass times gravity times mu cosine theta all over m. We found this using the free body diagram. To find the average time, we added up all our times and divided by the number of trials we had. We then plugged the time into the Vividet equation and found acceleration. After we found acceleration, we found mu using the acceleration we found and theta. Here's how we found mu. Wow, we're pretty certain. Throughout this lab, we measured various aspects such as the velocity, the angle of the ramp, the height at which the ramp was set, the distance traveled down the ramp, and the time it took for the cart to travel down the ramp. For many of the measurements, we used the most precise tools and methods high school students have access to. For example, we used photo gates to measure the time, and the distance traveled down the ramp was accurately taped and executed through the trials. In other labs, when we measure time, we would account for more than one cycle or revolution. For instance, the ball would spin around the pole 10 times before we stopped the stopwatch. Then we would divide the time by the number of revolutions, or 10 in this case. This would give us a more accurate reading of the time. Similar to that, to get a more accurate reading of velocity, distance, and time, we could use a longer wooden board, resulting in a longer distance. The longer distance would account for less error in time and velocity.